Okay guys, so today we're going to do 5.5, adding and subtracting fractions with unrelated denominators. And this unrelated denominator concept, you don't need to know the words, but you need to know the idea. When we look at these two fractions, I can't just convert and get an equivalent fraction that changes one fraction so it has the same denominator as the other. It's harder to do that. So today we're going to have to change both fractions. So if you want to try them on your own, you can, and then check with my work, or if you're going to follow along with me, that's okay too. So to start out, we have 1/2 plus 3/5. So I got to think about, okay, we got a whole cut into 2 with 1 shaded and a whole cut into 5 with 3 shaded. Now in this one, I think first, I'm like, can I change my halves into fifths? No, 2, 4, 6 doesn't work, and I can't change my fifths into halves easily. So I'm gonna have to change both fractions. Okay. So I have to think of I've got to think about my closest number, my factors, my multiples of 2 and 5, and the first one that they both go into. Well, 5, 10, and I know 2 can go into 10. So like I have to think of that first. I have to think about my facts first to think which one's going to work. And so I think, okay, well, they can both go into 10. Well, 5 times 2 equals 10. So this must be 2 halves, because we don't want to lose track of, we're getting equivalent fraction to 3/5. 3/5 times 1 equals 3/5. And then a half, I know 2 times 5 equals 10. Okay, so, and you might notice like, hey, look, this came from the opposite denominator. This came from the opposite denominator. That works every single time. There are some times when there's a smaller number that works, and great thinkers can get there. But if this is all you can get to right now, this will work for the vast majority. Actually, it'll work for all of them, but there's some that there's a better answer. Okay, so I just did, all right, 1 times 5 is 5, 2 times 5 is 10, 3 times 2 is 6, and 5 times 2 is 10. So then I do have to think for a second and come back up here and be like, all right, so a half was the same as 5/10, because 1/2 times 1 equals 1/2. So this half was actually 5/10. Okay, and again, I don't have to cross out that half, I'm just helping you see it, right? This is still a half plus 3/5. And 3/5, well, that was equal to 6/10. Now we've gotten a fraction with common denominators, which is what we need to be able to add. So now I'm just going to add them out. 5/10 plus 6/10, 5 plus 6 is 11, and the size of the pieces are still tenths. That doesn't change. But you can think now, a half plus 3/5 is 11/10. It's the same thing. And you would then think, can I simplify this? Well, 10/10 is 1 whole and 1/10 left. And I can't divide by a whole and get a simpler fraction, so this is my best answer. Okay, now let's show what's happening in the picture. So I'm going to draw 2 of the exact same size holes, the best I can. I'm not perfect, but that's what we're trying to do. Okay, and the first one I'm going to cut into halves. All right. And the second one I'm going to cut into fifths, although I'm going to do it the other way. It's not the law, but I like when my piece is, when it's very easy to see what I'm doing. Okay, and I'm going to shade in 1/2 here, and I'm going to shade in 1/5, 2/5, 3/5. Okay, so we got a half plus a fifth. So if this was cake, I could just take this and put it together and never name it, and just say, yep, I have added a half plus 3/5, but we want to be able to name it. So what we do here, if you think about this, and there's a reason why I did, on the second one I did my lines this way, and my first one I did my lines this way, is that I'm going to come to my 3/5 and cut them into halves. You see how I did that? Right? Because that's going to give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. 6 shaded, 6/10. I can see it now. I still see the 3/5. I also see the 6/10. And then on my half, I'm going to cut it the other way into fifths. 1, 2, 3, 4 cuts makes 5 pieces. And now you can see, now I've made all these pieces the same size. I still see the half, but now I can see fifths. 1, 2, 3, 4, 5, and I can also see tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths. So I can see that a half is just 5/10. So see, this picture shows what happened over here. It shows that 3/5 is 6/10, and 1/2 is 5/10. And when I put these together, I'm going to have 5, 6, 7, 8, 9, 10, 11 tenths. Or I can take 3, 4, 5 of these pieces, put them up here. That makes 1 whole, and there would be 1 piece left, 1 and 1/10. Boom. Tell your friends. Okay, let's try B. Now this one's tricky. This is one of those special ones I gave you an example of. So we have 5, 6, and 3/4. Okay, and I can't times 4 by something to get to 6. I can't times 6 by something to get to 4. So these are unrelated denominators. And okay, so I'm gonna have to change both. So I'm gonna have to times them by a whole, and we're looking for a fraction. And this isn't magical. The stronger your math facts, the easier it'll be to figure this out. Now, if you're using a trick, you might do 4/4 here and 6/6 here, and it's gonna work, but it won't be simplified. So I always think with these numbers, before I just use the opposite, is there a what's the smallest number they can both go into? And I usually use my bigger number to think about it, 6, 12. Does 4 go into 6 or 12? It goes into 12. Okay, so this is a special example, and I guarantee you on NWAs, on testing, they always give you a 6 and 4ths question to see if you have a strong enough understanding that you don't always use the opposite, even though you could. If you went 20/4 here, you still would get a correct unsimplified answer. You would just have to then simplify it. So, what times 6 equals 12? 2. So this must be 2/2. And what times 4 equals 12? 4, 8, 12, 3. So this must be 3/3. These have to be wholes because we're trying to get equivalence. 5, 6 is the same thing as whatever this is because we're timesing by 1. 3/4 will be the same thing as whatever this is because we times by 1. 5 times 2 is 10. And then 3 times 3 is 9. There we go. So now, okay, we can solve this. Notice that this says subtraction here. Got to pay attention. So 5/6 we just proved is the same amount as 10/12. And 3/4 is the same amount as 9/12. Right? And I have to look here. 5/6 is 10/12. 3/4 is 9/12. I could have written these 3/4 on top, 5/6 on bottom, so I have to pay attention to see what's going on up here. And I can add them up. I get 19/12, which in my mind I'm like, well, 12/12 is 1 whole. And then 12 plus 7 more is 19, so this must be 7/12. And I think, can I divide this by a whole? No, 7 and 12 don't have any common factors except for 1. So this is our best answer. Whoosh, that's what we're looking for. Now let's draw the picture. I'm going to draw 5, 6, and 3/4. Be careful, because watch how I do this. It helps. It's not the law. My 5, 6, I'm going to do this way. Boom. And my 3/4, I'm going to do the other way. And there's a reason for it. 3/4, I'm going to do the other way. And again, it's not the law. If you did them both the same way, it's not the end of the world. Okay? So, we changed these both to 12ths. So there are currently 6 pieces here, and I need it to be 12 pieces. Oh wait, I didn't shade it in yet, sorry. 5, 6. 5, 6, and 3/4. Okay. Kaboom. Now I need 12 pieces because that's what we have over here. And so I'm going to cut my 5, 6 into 2 pieces because that'll make 12 there. And again, you can kind of see it, 2 pieces here. So see, 5, 6 is actually 10/12, just like we had here. And then on this one, I need 12 pieces. There's currently 4. So I'm going to have to cut this into 3 pieces. Boom. And we get 4, 5, 6, 7, 8, 9, 10, 11, 12. I guess the crisscross didn't really matter here. And I can see that this is 9/12. There's 9 shaded out of 12 in the whole, so 9/12. So now I can see that 10/12 plus 9/12 equals 19/12. Or if I took 2 of these and filled in this space, there'd be 7/12 left. Now, don't be confused about my pieces aren't the same shape, but they are the same size theoretically if my holes are exactly the same. So 12ths are 12ths as long as the holes are the same. And there we go. We've got evidence. Actually, oh my gosh, I'm so ridiculous. Ugh, You guys saw my mistake. I'm sure you saw it 5 minutes ago. I made the same mistake I would harass a kid for making. That's what happens when you try to go fast. The mistake was simple. This is subtraction. 10 twelfths minus 9 twelfths would be 1 12th. Okay, so again, if we're over here and there's 9 twelfths, I got to take these 9 twelfths away from my 10 twelfths. So 1, 2, 3, 4, 5, 6, 7, 8, 9 taken away, and we have 1 out of 12 left. That's a ridiculous error. I'm sorry. Okay, let's go to the third one. Things are getting trickier now, but I always like to show mixed numbers because sometimes it freaks kids out. So the reality here is we could just mess with the fractions, not the wholes. You don't have to write the whole number down here because we're going to get the equivalent fraction will still have a 2. It's still going to be 2 wholes for it to be the same, to be equivalent. So you could do that. Some kids like to bring down the 2 2/3. I'm going to, for this time, just bring down the 2/3 and the 4/7. And we need to think of something we can multiply them by to get the same denominator. And we can see we can't turn 3s into 7ths, 3rds into 7ths, because 3, 6, 9 doesn't get there, and 7's coming back doesn't get there. So we got to think 7, 14, 21. 3 goes into 21. So these are both going to be able to become 21ths. Okay? Then we just got to think, what times 7 equals 21 and what times 3 equals 21? Well, 3 times 7 equals 21. So this has to be 7/7 because 3 times 7 is 21. This has to be a whole so that we get an equivalent fraction. And 7 times 3 is 21. And you see we're back to our pattern. 2 times 7 is 14. Sorry, I did some work in my head. 4 times 3 is 12. So we have proven that 2/3 is actually 14 21ths. And 4/7 is times 1 is still 4/7 or 12 21ths. Now we have common denominators, so we can add. Now, this is where things could get tricky, because technically, this is going to be just the 2/3 is 14 21ths. So this is 2 and 14 21ths. And this is 4/7 is actually 12 21ths. So this equivalent fraction is 1 and 12 21ths. Now, just so you can see it, you don't have to go back and do this. If I had put my holes here, this still makes sense because you do 7/7 times 2/3, which is 14 21ths. And then I'll think of this as one whole. 7/7 times 2, 1 whole times 2 is still 2. And 1 times 1 is still 1. So that's why we can just keep these or not write this. Okay, now let's add them together. 2 plus 1 is 3. And 14 plus 12 is 24, 25, 26 out of 21 still in the whole because our denominator is just the size of the pieces. And then we're going to simplify here because we can. This is a correct answer, by the way. This is still correct. But we know 21 21ths would be another whole. So this is 4 wholes. And then 21, 22, 23, 24, 25, 26, and 5 more 21ths. That's our very best answer. Okay. Now, we could draw this, but once the numbers start to get bigger, the drawing's less important. I mean, it's still really important. It's easy to make mistakes. So don't get away from the drawing. Know how important it is. But as the numbers get more complicated, we use the drawing less. The same way when we were learning multiplication, with small values, we draw it out. But when the values get bigger, we need a symbolic method so that it's not so cumbersome. It doesn't take us so long. All right. Last one. Don't let me mess up this one. Subtraction. Okay. So we have 2 5/8 minus 2/3. I'm going to do 5/8 and 2/3. Okay. And I need to think of a number that both 8 and 3 can go into because I can't think of anything times 3 that equals 8 or anything times 8 that equals 3. It's only kind of true. It would just be a fraction, and we don't want that. It's got to be a whole number. So, all right. What could it be? I always start with my bigger looking digit. 8, 16. Nope, 3 doesn't go into 16. 24. 3 goes into 24. So I can change these to 24ths. So what times 8 equals 24? 3. So this has to be 3/3 because we have to multiply by a whole. And what times 3 equals 24? 8. 8/8. And you can, again, look at this pattern, how we can always use the opposite denominator to do things. to figure out what the common denominator is going to be. Although there are some exceptions, like with 6 1/4, where we could have done that, but we would have ended up with 24ths. We would have ended up with the equivalent of 24. So we would have ended up with an answer of 2 24ths instead of 1/12. They're equivalent, but it's better to be simplified. So we can, but this little pattern of seeing the opposite is super useful. So 5 times 3 is 15, and 2 times 8 is 16. Okay, now here's where we have to be so careful. Which one of these, oops. Oh, I don't know why that just came up there. Get out of here. We don't want you there. What are you doing? Get it gone. Okay, which one of these, 15 24ths or 16 24ths, was 5/8? 5/8 was 15 24ths. So we got to come back, and we're going to replace it with 15 24ths. They're equivalent. And the 2/3 we're going to replace with 16 24ths. And hopefully now you're seeing a problem. Okay. The problem here is that we don't have enough 24ths. There's 15 here, and we need to take 16 of them away. So we need more 24ths somehow. There's 2 ways people do this. Some will go completely to an improper fraction. I'm not going to go completely to an improper fraction. I'm going to take one whole. Just take one. So the whole, I subtracted 1 from here because I took 1 whole, and that would be 24 more 24ths. So I have 15 24ths plus 24 24ths. That's 34, 35, 36, 37, 38, 39. I just added 24 24ths plus 15 24ths, and I got 39. Oops. I got 39 24ths. Sorry about that weird mess. Okay. Now I can subtract. Now I have enough. Okay. So I go 1 minus nothing. That's still 1. And 39 minus 16. Well, 39 minus 10 is 29. And then take 6 more away, and we get to 23. We get 23 24ths. Which a lot of you probably could have even figured out without this borrowing situation or regrouping. Because you might have said, like, well, 15 24ths minus 15 of these 24ths would get us to 2. And then it's just 2 minus 1 more 24th. Oh, yeah, that's 1 and 23 24ths. So this is our correct answer. I will say with these subtracted ones are the toughest ones that you can get, right, when you have to regroup on your subtraction. It doesn't always happen, but it sometimes happens. And the mistake a lot of kids will make is when you get lazy, they just look at these two and say, oh, the difference between these is 1 24ths. So they'll call the answer 2 and 1 24th, but it's not. And I can show you that in a picture, although I don't really want to do the picture because this is going to be kind of huge here. Although, you know what, I'll do the picture for this last one, just because why not? So let's do 2 and 5/8. 1, 2. Okay, that's going to be my 2 and 5/8, and then this other piece is going to be my 2/3. So I'll do my 2/3 here. And then my 2 wholes, 1, 2 wholes, and 5/8. 1, 2, 3, 1, 2, 3. That should be 8ths, but I got to double check. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And I need to shade 5/8. Up to 5/8. There we go. So we have 2 and 5/8, and we need to take away 2/3. So the first thing I'm going to do with this 2/3 is I'm going to cut it into 8ths. I'm going the other way. 1, 2, 3. Ooh, it's getting ugly. I'm going to scroll in a little bit just because it helps me. 1, 2, 3. So this is proof that 2/3 equals 1, 2, 3, 4, 5, 6, 7, 8, 16 out of 24. You can see it. Right, 16 24ths. Now here, I'm going to cut this into thirds going this way. Those aren't perfect. And I can see that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 24ths. I have to take this 16 24ths away from here, but this is only 15 of them. I need to take 1 more away. So I need 24ths up here. So I'll go 8ths down. It's okay if you don't draw this. I just want you to really understand it. Okay, and I would have to take, I've only taken 15 away. I need to take my 16th away. And what do we have left? We have 1 whole and 3, 6, 9, 12, 15, 16, 17, 18, 19, 20, 21, 22, 23 of the 24th. And you can see it in the picture. So it does match. It's just kind of hard to show it because it's so big. There we go. It shouldn't be much different than yesterday. We're adding and subtracting fractions with unrelated denominators, which means we have to change both fractions instead of just one. It's not really that much different, just a little bit different thing. All right, hope that helps, and let me know if you have any questions.